Hi, in this video we're gonna use MATLAB to compute or find the equation of a normal line to a curve. We're also going to sketch the normal line and the tangent line along with the curve. So this is the book that I'm borrowing this problem from. It's my calculus book. It's 14th edition, Calculus Early Transcendentals. It's a very good book. This is the book I use to do all my MATLAB videos and look at calculus problems and so on. All right, so let's go to the page where we're going to look at the problem. It's in page 163. Let's make this bigger. So we're going to be looking at this problem here, 55A. So it says, normal line to a curve, find an equation for the line perpendicular to the tangent line to the curve y equals x cubed minus 4x plus 1 at the point 2, 1. So let's quickly look at a sketch of what this problem is asking. This is a general sketch of any, just showing you normal lines and tangent lines in relation to a curve. So say we have a graph like this. Let's put our coordinate system in there. So let's say we have a, I don't know, let's make this a parabola. I know in our problem we're looking at a cubic function, it's x cubed. But let's look at this parabola and we're looking at, say, a point here, for example. Put a point right here. Tangent line then would be a line that is striking the point. It's an instantaneous rate of change. So it is the slope of, it's not a slope, an equation of a tangent line, but this is a line that goes through that point of that curve. So, and then the normal line would be a line perpendicular to the tangent line. So it would look something like this. So our normal line is like so. And this angle here then is 90 degrees. 90 degrees. So that's what we're looking at here. So we have a curve. They're asking us to find the equation of a normal line at a given point. All right, so let's go back to the problem. Let's actually open up MATLAB. Let's open up MATLAB. So we already seen the problem. I put in the problem in MATLAB already, and I've already done CLC, close and clear all the variables. So we are going to be doing this symbolically. So I've defined x symbolically here. So what we're going to do now is we're going to put the rest of the code in. So let's start by copying and pasting the given problem or the curve that they give us. And so we're going to say x equals, let's see. So we're looking at 2 and 1. So x1 equals 2 and y1 equals 1, like so. All right. So what I'm going to do now is I'm going to plot the curve and see how it looks like along with the grids and everything. So we're going to say f equals f plots y. And then let's set, so we're going to set f with a color black, so B, and then, oops, and do line widths. Let's do a line width of 2, and then we're going to hold on and grid on so we can put in more graphs. Like, all right, grid on. All right, like so. So let's go ahead and run this and see what we get. So we're going to add it to the path. All right, so this is the graph of our curve. We can make this a little bigger. So it looks like later on we're going to put the x and y coordinate system in there. So it'll look nicer for us. But if you look, it's a cubic function, and we have the point 2. We're interested in the point 2, 1. So that's what we're going to look at. All right, so now let's go back to our code, and we're going to put in more things. So I'm going to say dy equals diff y. So we're going to take the derivative of the curve, and we're going to say m equals subs dy x1. So to find the slope of the tangent line, we need to evaluate the derivative at x1, at the point of the coordinate system, the x coordinate point. All right, and so then m1, this is going to be the slope of the normal line, so this is negative 1 over m. It's orthogonal or perpendicular to the tangent line. So then normal equals m1 x minus x1, m1 times, don't forget the symbol like that, and then plus y1. All right. And then we're gonna do a fprintf command. So fprintf. So let's see. We're gonna say the equation of the normal line is y equals %s. So this is this string version of it, and then we're gonna do twice, two new lines, \n twice, and then come out here and normal. Oops, like that. All right. All right. So let's see. Let's go ahead and run it again. I'm gonna comment this line. We don't want to graph it again. So it says the equation of the normal line is y equals 5 over 4 minus x over 8. It's a slope-intercept form. All right, now let's do the graph of all of them together. So we're gonna graph we've already graphed the curve, so let's go ahead and uncomment that. So now I'm gonna graph the tangent and the normal line also. All right, so this is our graph here, and let's make this bigger now. So we have our curve plotted. We have a legend there, but this is our curve in blue. Our tangent line is red, and the normal line is green. We form a 90-degree angle because the tangent and normal are perpendicular or orthogonal to each other. And we also plotted the x and y coordinate system axis, x and y axis, and we have grids, and we have a legend here distinguishing which is which. So this is how we compute. And if we go back here, it tells us what the equation is, and we also graphed. So we computed the normal line, we plotted the tangent, normal, and the curve together. Thanks for watching.